Hi guys, welcome back to the start of a new year, 2021. We are just starting a 2-week unit and it's going to be on chemical and physical properties and reactions. This week we're going to be focused on chemical reactions and next week we'll be focused on physical properties, physical reactions to things. So I'm going to start out by sharing a PowerPoint and quickly going through the content, and then we will switch over to some demonstrations. Taking a quick look here at our slideshow. So chemical and physical changes. Sometimes we say chemical physical properties or reactions. All means the same thing. So this week starts out with a bunch of vocab. People always say, oh, I hate vocab, but I'm going to be using these words, so I want you to be comfortable with them. You can pull these words, the definitions for these words, right off of Quizlet. There's a link to Quizlet on my class page. So we're looking at chemical changes, and chemical changes are precipitates. We need to understand exo and endothermic, catalysts, the reactants, products. And then next week, we will go into the physical changes, states of matter, knowing the difference between a solid, a liquid gas, and sublimation. So to start off this week, how do you identify a chemical reaction? Well, there's going to be a series. I think that there were 4 things that we're looking for with a chemical reaction. The first, we would look for a new substance or a precipitate, and I'm going to show you a demo of that before this video is over. So the first thing we're looking for, a precipitate. Usually the word precipitate means that stuff coming down from the sky, rain, snow, sleet, or hail. Instead, this is going to be a solid particle that will, in a sense, rain through a liquid. Next thing, gas, odor, bubbles. We're talking about stinky stuff, bubbly stuff. Anytime we see a weird green gas coming up off of a reaction, you do not want to stick your nose in it. We do not whiff in science class ever. Rather, the proper way, it's called wafting, and you just kind of bring the odor up towards you. Don't ever whiff, only waft. That's evidence so that a chemical reaction has occurred. If there is a temperature change, and those temperature changes, we're going to call them exothermic or endothermic, that is solid proof that a chemical reaction is occurring. And last, some kind of a color change. If I take this chemical, mix them together, and poof, I get a whole new color, that's evidence that a chemical reaction has occurred. So taking a look at some graphs here, exothermic or endothermic? Well, we've got our reactants. And again, this might not mean a whole lot until you've gotten through that vocab. Our reactants are the things that we start with. When we mix them together, and the graph goes up, 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 bam, we get a reaction. And as that comes down, it yields or produces these products. That's going to be the gas. That's going to be the heat. That's going to be the new substances. If the products are not all the way down here with the reactants, it means that they went in, everything went in, it happened, and bam, the products are up higher. So it says that energy is subtracted in an endothermic reaction. Endo is going to mean in. So this reaction would get colder. Whereas this one, with our reactants starting up high, when we mix them together, and this activation energy makes the reaction occur, our products sit much lower. That's showing us that heat has come out. So this is going to be an exothermic reaction. How do reactions get started, chemical reactions? Well, we need something called activation energy. It's just like if you're sitting on your bicycle and you want to start to go forward, usually you give yourself a little shove with one of your feet, you push off. That's the activation energy. Well, chemical reactions also need activation energy to make them happen. So what might be that activation energy? Well, increasing the temperature or decreasing the temperature might affect the speed or how quickly a chemical reaction occurs. The surface area, the sides, how many sides are exposed is going to affect it. Stirring or mixing might speed up a reaction. The concentration, if we have a very strong solution, we're going to get a faster reaction. In the presence of something called a catalyst. And a catalyst is a substance that causes a reaction to speed up when we add it. So I'm going to stop my screen sharing here and bring us back. I'm going to set up a couple of demos for you. And there.
Mm-hmm. Oops, you're recording.
So this week, you're going to be doing a lab, taking a look at the difference between chemical and physical, not just reactions, but properties. You're going to, I think right before Christmas vacation, you got 2 little tablets, little denture cleaner tablets. Don't eat these, all right? They're soap. They're going to make you sick. So don't eat them. These denture tablets have a chemical reaction with water. And so that's what you're going to be doing this week. The first thing you're going to do is your first tablet is going to need to be cut in half. So I used a sharp knife and I kind of scored it, which means I made a line on it with a sharp knife. And then I proceeded to break it in half. That is a physical change. I have physically changed the shape and the size of the denture tablet. The other denture tablet, and you're going to read the directions, you're going to crush it up. Crushing it up is also going to be a physical change. It is still the denture tablet, it's just in a different shape, a different form, or a different size. And then you're going to end up adding water to them. As you go through the directions, it'll tell you how to place them in the containers. The water reacting with the denture tablet is going to be a chemical change, because whenever there's a chemical change, you chemically alter the chemical composition. You change what the substance is, and you can never make it go back to its original form. So this week's lab, chemical and physical. Now, from the PowerPoint that we just looked at, there were some things that affect the rate or the speed of the chemical reaction. You're going to be taking a look at the first 2. You're going to be looking at the temperature of the water and how that changes the speed of the reaction. And you're also looking at the surface area, that is the sides exposed, a solid piece versus a crushed up piece of denture tablet. In our next experiment, we'll take a look at the stirring and the concentration and how those are going to affect it. So let's move on to our little demos here. Remember, we're talking about chemical reactions. Whenever there's a chemical reaction, we are chemically changing or altering our substance and creating a new substance. We can never go back. So our first one we have, you ready? I've got a clear container so you can see the reaction. I've put hydrogen peroxide in here. Hydrogen peroxide is something you probably have in your medicine cabinet. I put a thermometer into it, and when I get right down at eye level and read it, I don't know how well the camera can see it, but it shows that at a temperature of about 20 degrees Celsius, which is room temperature. That's probably like 67, 68 Fahrenheit. I'm going to add some yeast, the kind of yeast that you would use when you make bread or rolls at your house. Hydrogen peroxide plus yeast. To my cameraman, Dave, what do you think's going to happen when I mix these 2?
Oh, I bet they're going to get hot.
You think? So I'm going to put that in there. We don't see much happening, but if I want to speed up a chemical reaction, number 3 on here says that I can stir it. So when I take my thermometer and I stir it a little bit, boom, what do we see happening? A mess, a mess, a mess. So we know that a chemical reaction has occurred. Think back to that PowerPoint that I just did here. Chemical reactions. One piece of evidence that tells us a chemical reaction has occurred is that there is a gas produced, an odor, or bubbles. Now remember, or maybe you guys don't know, I don't have a sense of smell. I can't smell at all. So to my cameraman Dave here, who has a very keen sense of smell, remember, you don't stick your nose in and whiff. Instead, you bring it up towards you, you waft. So cameraman Dave, bring that nose in here. Waft. What's it smell like?
I smell yeast.
You smell yeast.
I just smell yeast.
Does it have a good odor or is it yucky?
Well, I like the smell of yeast, so it smells good to me.
Alrighty. I'll tell you, every year when my students do this experiment, they're always like gagging and carrying on about it. Well, I'm going to mix this up here and let's take a look. Remember, it started at 20 degrees Celsius. We added the yeast, and can you see, cameraman Dave, has the temperature changed?
Turn towards me a little bit. To the way. Yeah, we can tilt the other way. The other way. There you go. Oh, right there.
Did the temperature go up?
It says 30.
Excellent. So when we added yeast to hydrogen peroxide, we got those gas bubbles, we got those odors. We also got a temperature change. And this temperature change, it got warmer. So what we call that is an exothermic reaction. Exo means out, like an X, your X is on the out. Thermic, thermometer, is temperature. So an exothermic reaction, it puts heat out. So we feel the heat in this reaction. So heat comes out or it gets hot. I want to show you one other thing that goes with that, maybe. Here it is. In this exothermic reaction, I took plain old H2O2, which is what hydrogen peroxide is. And people always say, can I drink hydrogen peroxide? Will it kill me? Actually, hydrogen peroxide is what a vet gives an animal if they need the animal to throw up. It'll make you throw up, all right? So H2O2 plus yeast, it yields, that's what the arrow means. I take these reactants, put them together, it yields or creates the following products. It gives me H2O, which is just water, O2, which is oxygen, that's the gas bubbles, and heat. This is the exothermic reaction with the reactants and the products. One more experiment let's do here. We did our our heat out reaction. Let's do our other one. In this one, I've got vinegar, just household vinegar, and baking soda. And probably most of you guys have done this experiment. If not in science, you've probably played with it at home. Now this one, taking a look at the temperature. Can you zero in on it? It should be pretty close to what the other one was at 20 degrees Celsius because it's room temperature and they've been sitting here for a little while I was making my video. So I'm going to take some baking soda. And if I just put a little tiny bit of baking soda in, I get a little bit of bubbles. But I want to up that concentration, which was one of the things I can do to speed up a chemical reaction. Okay, I can increase the concentration. That's the fourth thing here. So I'm going to increase that concentration. I'm going to put a big old spoonful in there. I'm going to stir it to speed up that reaction, and woo-hoo-hoo-hoo! What a fabulous mess. Now we're getting gas. There's definitely an odor to it. We're getting lots of bubbles. We're not getting any solids or precipitates. but we are getting possibly a temperature change. No color change.
Right, don't
So-
touch the thermometer. Just right.
Oh, I screwed it up. So we had started at 20. Did it go up or down? Yes. Did it go down? And what does it read?
Looks like 15 here.
Down to 15. All right. So we went from 20 to 15. So this one was our endo reaction, endothermic. Endo means in, thermic, thermometer means temperature. So this was heat goes in and it gets colder. This one had to pull the heat in. And if you think back to our PowerPoint from just a few minutes ago, that chart, it shows whoop, and it doesn't go all the way down. It holds that heat in. So there was one other experiment I wanted to do for you. And stay right here. We're not going to pause it or anything. I want to see if I can create a precipitate. And we're going to create a precipitate by taking some whole milk. And we've got to curdle that milk by adding some lemon juice. Let me find a clear glass. Let me use one of these. Clear a little space. So I've got some whole milk, and whole milk has a lot more fat in it than our 2%, 1% or skim milk. Oh, it's a waste of good milk, right? Put some milk in there. I'm going to take some lemon juice. Pour a bunch of lemon juice in there. Let's see if we're getting anything. Ooh. Can we tell that the consistency of the milk is a little bit different? In fact, can the camera see?
Run up the side of the glass there.
Yeah, what we've done is we have chemically changed or altered that milk by mixing lemon juice with it. And when these two, when the milk, the fat in the milk and the lemon juice chemically combined, it created a precipitate or a solid. So we've done almost all of the things here. From my chart, we can tell that a chemical reaction has occurred when we get a precipitate or a solid, when we get gas, odor, or bubbles, which we got from these two definitely, and whenever there's a temperature change, our exo and our endothermic. The only one I don't have today is the color change. That's a much longer, pretty complicated lab. And if we are lucky enough to get back to school next week, we will do this lab together. Otherwise, I'll get a video together of it for next week. So this week, chemical and physical changes, chemical and physical reactions, chemical and physical properties. You're going to start by doing your lab with the denture tablets. Read the directions right from the lab sheet. And you also have some vocab that has to do with all the vocabulary I've been using in today's lesson. So that's it. I'm hopeful that you come to my 9 o'clock lesson on Monday morning. If not, pop into office hours and have a good week, guys.